Welcome to Electronics Shikshaalaya, and you are watching Signal System Lecture Series. And today the topic of discussion is the manipulation of discrete time signals. So in this case, we'll see how the time shifting property will apply to the discrete time signals, then time scaling, okay, then time reversal property of discrete time signal. Then at last we will see the amplitude scaling of the discrete time signals. Okay. So this is very important for your means examination point of view. Okay. So we'll see that in details one by one. Okay. So let us get into the details. So first property is the time shifting property of the discrete time signal. Okay. So how the shifting time shifting occurs? Let us see that a signal that is the a signal x of n is a discrete time signal. Okay, x of n is a discrete time signal that will shifted by the replacing n by the n minus k, where k is an integer. So that will be shift by k. Okay, that is integer. K is an integer. So it will shift the x of k in time. Okay, by replacing n by n with n minus k. Okay, that is the k is an integer. Okay, so mathematically it is can be expressed as y of n equal to x of n minus k. Okay, where k is an integer. So we are shifting the x of n with time, that is t. Okay, and that is the time k. Okay, so k is a integer. Okay, so let us see. So if k is a positive integer, then the time shift is the delay of the signals by k units of time. If k is a positive integer, then you have to delay the signal by k units of time. Okay. Similarly, if k is a negative integer, then we have to advance the signal by k units of time. Okay. So this is the means shifting property. So if k is a means positive, you have to delay the signal by k units of time. If k is a negative integer, then you have to advance the signal by k units of time. Okay. Let us take by an example. So x of n is graphically illustrated in the figure. So in the figure, actually x of n will be given to you. So you have to find out what is x of n minus 3 and x of n plus 2. Okay. So let us see that. So this is our x of n. The signal is x of n is given. That is the. So you have to perform x of n minus 3 and x of n plus 2. Okay. So let us see that. So x of n minus 3 is obtained by delaying. So here the k is a positive integer. So you have to delaying the x of n by 3 minutes of time. Okay. Similarly, if with the signal x of n plus t 2 is obtained by advancing the signal x of n by 2 units in time. Okay. So let us see first x of n minus 3. So here k is a there is a k equal to positive. Positive means you have to delay the x of n by uh, that is the 3 units in time. Okay, so 3 units in time. So let us see the delay the signal means you have to means delay means you have to actually uh, shift the signal right side. Okay, shift the signal right side by 3 units of time. Okay, that is the signal. So if the x of n, you have to delay the x of n by 3 units of time. So that means you have to shift the signal towards the right. Okay, towards the right. Okay, that is the meaning of delaying the signal x of n. Okay, so you can see if we delay the signal by 3 units time, means this signal will be get shifted towards the right by 3 units of time. Means again it is started to x of n is starting from minus 5. Delaying means it will start from uh, this minus 2. Okay, then it will go up to the 5 6 7. Okay, 5 6 7. Okay, so let us see that. Okay, so you can see over here. So x, this is x of n minus 3. So we have shifted the signal towards the right by 3 units in time. 3 units in time. So again, you have seen that this is minus 2. Then only we are actually we are executing the time axis. Okay. So here shifting the signal towards the right by 3 units of time. Okay. So it will start from minus 2 and it will end at 7. Okay. So this is how you delay the signal by 3 units of time. Okay. So let us see now how to advance the signal x of n by 2 units in time. So advance means you have to shift the signal towards the left. So this signal will be shifted towards the left. by 2 units of time. Okay, so this is the means x of n, so 2 units of time, so it will start from here. Okay, so it will start from this side. Okay, this side you can shift the signal towards the left. Okay, by 2 units in time. Okay, so it will have 2 over here, then it will be minus 7. Okay, so let us see that. Okay, so this is the x of n, that is the plus 2. So what we have done is that we have advanced the signal by 2 units of time, means you have to shift the signal towards the means left side. Okay, so this is the meaning of advance or delay the signals by that amount of time. Okay, so let us see that. Okay, so you can see that this is the delay means you have to shifting the signal towards the right. Okay, delay means the shifting the signal towards the right, whereas the advance means shifting the signal towards the left. Okay, so this is actually for time shifting property, where you can see this is n. Okay, so if n minus k is a integer, if k is a positive, so what will do? If we delay the signal by q units of time, delay means it is the shifting the signal towards the right. Okay, similarly, if k is a negative integer, that you have to advance the signal. Advance the signal means you have to shift the signal towards the left. That's all. Okay, so this is our time shifting property. Okay, let us see our second property, that is the time folding or time reversal. Okay, our second property is a time shifting or time reversal. Okay, so let us see that. So this is the another useful property. So it is means that we can see in this case what we are doing is that it is the folding or reflection of the signal about n equal to 0. So you have to fold the signal at n about the n equal to 0 axis or time origin n equal to 0. Okay. So this is the actually mirror image of that signal. Okay. So let us see that. So the graphical representation. So this you have to graphically represent it. Okay. So you have to shift this signal. So you have to find out x of minus n means reflection of the signal about this n equal to 0. So this signal will give means this signal comes over here. This signal comes over here. Likewise, this signal comes over here. This signal comes over here. So this is the shifting means this property is the folding or reflection of the signal about n equal to 0. This is actually the mirror image of this x of n. So let us see that. So you can see this is x of n is reflected or folded about the time origin. Okay. So this is our x of minus n. Okay. So we have folded the signal about this time origin. Okay. About this time origin, we have folded the signal. So this sample 1 will be minus 1. This 2 will be minus 2. Then this sample 3, that will be in the minus 3, and 4, that will be in the minus 4. Likewise, you can see over there. Then this minus 1 sample will be 1. Then minus 2 sample will be at 2. Then whatever is there in the minus 3, it will go to 3. Okay. So this is how you have to means fold the signal. Okay, about this time origin. This is the mirror image of that x of n. Okay. So this is the then what we are actually you have to there is in the question actually two things are given. Okay, first one is so what is we have done is that x of minus n. Okay, so the graphical representation of the signal x of n and x of minus n plus 2. Okay, there is a minus n plus 2. You have to find out what is x of minus n plus 2. This is our x of minus n. So how to find out the x of minus n plus 2? So x of minus n plus 2 is simply the x of minus n delayed by 2 units in time. So you have to delay the signal by 2 units per time. See, this is actually reverse of that. So if this x, we have performed x of n, if it is n plus 2, then you have to advance the signal. Okay, you will advance it. But here is it x of minus n plus 2. So you have to delay the signal. Okay, this is the reversal of that. Okay, time shifting. Okay, so that is why you have to here. In this case, you have to delay the signal. Okay, but if there is positive n plus 2, then will be advance the signal. Okay, so let us see that. Okay, so this is the case. So you have to delay the signal by 2 units of time. So you can see delay the signal means you have to means shift that signal towards the right. Okay, so you have shifted the signal towards the right side. Okay, so you have shifted the signal towards the right side. Okay, so right shift. Okay, delay means here the right shift. So you can see there is a right shift of by 2 units in time. Okay, so this is the time folding or time reversal property. Okay, this is the second property of the discrete time signals. Okay, so let us see uh, our next property, that is the time scaling. Okay, so time scaling property, we can see in this case the third modification of the property is the time scaling property. So in this case, what we are doing replacing n with mu f n. Okay, so where mu is an integer, so this is called the downsampling also. Okay, so for example, so the graphical equivalent signal, so x of 2n you have to means perform. So here we are scaling the signal by 2 units. Okay, so you can see this is the x of n is given, that is the x of n. So we have to perform x of 2n. Okay, so let us see how it is happened. So x of y, x of 2n. So how to find out, sorry, y of n? By taking every other sample of x of n starting from x of 0. Okay, so here you can see x means x y of n equal to x of 2n. Okay, so how to find out? So y of 0, if I put n equal to 0, it will be x of 0, the same sample of x of 0. Similarly, if we not y of 1, so it will be x of 2. Okay, similarly, if we calculate y of 2, y of 2 will be x of 4. So we are taking every other, that is why we are taking every other sample of x of n. So we are not taking x of n and x of 3. Okay, we are taking other samples. So that is x of 0, x of 2, x of 4, then x of 6. Okay, similarly, in the negative ratio, it will be y of minus 1 equal to x of minus 2. Okay, minus 2. Y of minus 2, what will be y of minus 2? It will be x of minus 4. Likewise. Okay. So taking every other samples of x of n starting from x of 0. Okay. So that this is the, in other words, we have skipped the odd number of, means we have skipped the odd number of samples and returned the even number of samples. Okay. So let us see on this diagram. Okay. So this is our y of n, which is x of 2n. So we have skipped the means even number of samples. Okay, sorry, we have skipped the odd number sample. We have returned the even number sample. So even number sample, you can see minus 6, it is minus 3. Okay, similarly minus 4 is there. Okay, the minus 4 0, then this is 0. So similarly minus 2 is there. Okay, so minus 2 is there. Okay, this is minus 2 in the minus 1. So 0 is there, this is 0. So y of 1 equal to x of 2. So x of 2 here. So this is the y of 1. Okay. So on so forth. So this is the property, that is the time scaling property. Okay. So next one is where we have done the time modification. Now it is the amplitude modification term. Okay. So amplitude modification actually modification actually includes the addition, multiplication, and scaling of discrete time signal. Okay. So this is the thing. Uh, so let us see that. Uh, Now, so amplitude scaling means a signal that is multiplied by A. So it is accomplished by the multiplying the every sample by A. Okay. So every sample you have to multiply by A. Okay. Suppose x of n equal to one, 1, 2, and 3. So it will be y of n, and A equal to 2. So that will be y of n equal to, that will be 2, 4, and 6. So this is our, we are multiplied every sample with 2. Okay. So this is how the amplitude scaling. Similarly, so we have the sum of the two signals x of n and x of 2, that can be find out by summation of, so each sample you have to means add. Okay, at that instant of time. Okay, so each sum means suppose y x of n equal to x1 of n equal to 1 to 3, 1 to 3, and means x2 of n equal to 3 to 1. Okay, so you have to means add this is sample. So it will be y of n. So because it is starting at here, this is starting at this position. So it will be 1 plus 3, it will be 4, then 4, then 4. Okay, so this is y of n. So we are adding is sample. Okay, is position of that sample to have these two signals, that will be added. Okay, to that at same instant. Okay, you, that is the thing, means summation of two samples. Okay, similarly the product of two signals is similarly to sample basis. You can see sample to sample we can means multiply. So that will be our y of n equal to x of 1 n into x of 2 n. So this is our product of the two signals. Okay. So that is the we have seen the time scaling property. Okay, and time shifting property. And then we have this is the uh, reversal property, time reversal property. Then we have seen the uh, means amplitude modification of like addition, multiplication, and scaling. Okay, so that these are very important for the exam point of view. Okay, so thank you all. Thank you for watching this video. So if you have any doubt, you can free to ask me in the comment section. Thank you all. Have a nice day.